Hey guys, so this is your trainer Anirudh Chhillar. So we are back with one more video of OSPF. I hope you are learning in a good way and a good pace. So let's go for the next video.
So today, because we have to discuss about virtual links, so I have created this type of diagram in which we are having discontiguous areas. Like here you are having area 0, then you are having area 1, and you are having area 2. It means that area 2 will not be directly connected with area 0. And if area 2 is not directly connected with area 0, it means that area 2 is not gonna to communicate with any other area here in this diagram. But if you really want to establish communication between those, between area 2 and area 1 or area 0 as well, then you have to configure here virtual link, as I discussed a lot of things in previous class. Do you remember? I didn't configure virtual link, but I discussed a lot of things with you, right? Like we can also solve this problem by using GRE tunnel, or we can also solve this problem by performing ray distribution, right? So we have to use all of them. We have to use all methods to solve this problem. Can you hear me properly? Okay, so let's start it from R1 itself. So say router OSPF1, router ID 1.1.1, and then because on all interfaces of this device we are going to enable area 0. So you will see that area 0 will get enabled on all interfaces of this device. Now you can move on R2, and on R2 router OSPF1 router ID is 2.2.2, and see here on its S1 by 0 I'll be enabling area 0. On its loopback 1 also it will be area 0, and then on its S1 by 1 it will be area 1. So in this way I have enabled OSPF here as per requirement, as per this diagram. Then we can also move on R3. On R3 you know very well that yes, router ID is going to be 3.3.3, and then you will see that all interfaces of this router are in area 1 only. So network 000, 245, 245, 245, and area will be 1. So you will see that now on all interfaces of R3 area 1 will be enabled, and now you can see that R3 has formed neighborship with R2. Then you do one thing, move on R4, and then on R4 router OSPF1 router ID is like 4.4.4. interface serial 1 by 0, IP OSPF1 area is what? 1. Then interface loopback 1 will also be in area 1, but interface S1 by 2 will be in area it will be in area 2. So IP OSPF interface brief, you can see that okay, we are having this diagram here. We have enabled OSPF in this manner. I think loopback is not there. Okay, interface loopback 1, IP OSPF 1, area is 1. Show IP OSPF interface brief, check it out. Okay, now move on R5. You know very well that on R5 router OSPF1 router ID is going to be 5.5.5 network 000, and it will be using area 2. Then finally we can move on R6. On R6 also all interfaces will be in area 2. That's it. Have you understood it now? Have you understood it now completely? Fine. So previously, already I have taught you that in case if ABR is not there and you are receiving type 5 LSS in any area, it means that you will not be able to install them in your router's routing table, because if advertising ID is not reachable from your area, then definitely your routers are not going. Your routers will never install them inside their routing table. So this time, if I perform any redistribution on R1, of course it will generate type 5 LSS. It will give to area 0, area 1, as well as area 2. But all routers in area 2 will not be. It will not be possible for all devices of area 2 to install them inside their routing table. Have you understood it or not? Tell me. So we have proved it, all these things we have already proved. Now it is not necessary for us to perform this practical, right? But let me tell you one thing here. I mean, here now it is mandatory for us to have an ABR for area 2 as well, right? Because if there is no ABR for area 2, like you can move on R6, and on R6 you can see show IP OSP border router. There is no ABR available. Show IP route, you can see that how many routes are there. See, it is receiving only and only intra area routes, not inter area. Have you understood it now? It is receiving only and only intra area. Whereas if you move on R1 and if you check routing table of R1, then you will receive intra area as well as inter area. Only those inter area prefixes which belongs to area 1 only, because only and only area 1 is directly connected with the backbone area, right? So this time if you configure this command here, show IP OSPF border router on R1, you can see that R2 is working as an ABR. Fine, good. So now question is that how we can establish connectivity in between area 2 and other areas. First of all, I will achieve it by performing redistribution. First of all, I will achieve this task by performing redistribution. So let's do one thing. Let's move on R4, and from R4 remove your process first of all, and then say router OSPF1. Router ID is what? 4.4.4. Interface S1 by 0. IP OSPF1. Area is what? 1. Then on its loopback as well we can enable area 1. Then we can run another process 2. Router ID is 40.40.40.40, and then you can move on S1 by 1, and then you can say IP OSPF2 area is also 2. So it will form neighborship with R5 as well. So IP OSPF neighbor, because you know very well in OSPF it is not mandatory to match their process IDs, but it is mandatory to match their area IDs. So this time you can see show IP route, it is receiving all routes whether it belongs to area 0 or area 1 or area, I mean to say it is receiving intra area as well as inter area as well as inter area prefixes both. So here you can see 60s prefix, here also you can find 10s network as well. So everything, I mean all networks are there, all prefixes are available in the routing table of R4, because now all prefixes are available in the routing table of R4. So now we can perform redistribution, because here we are running two different processes. So you do one thing, say router OSPF1, say redistribute OSPF what? 2, and then say subnet. Then say router OSPF2, redistribute OSPF1, and then say subnet. This time you must be able to see all prefixes available on R1. Let me show you. 60s prefix is coming, right? Even you can see show IP OSPF border router. Now R4 is working as an ASBR, and we are getting this information here in the form of type 4 LSA, because for area 0 we are having an ABR here. Hey guys, just try it. And for area 0 we are having an ABR. R2 is working as an ABR for area 0 as well as area 1. So of course in area 1 there will not be any requirement of generating type 4 LSA, because ASBR is existing in same area. So if ASBR is existing in same area, then will it be required to generate type 4 LSA? No. Of course no. So because ASBR, which is R4, is available in area 1, that is why inside the database of area 1 you will never get type 4 LSA. But whenever these type 5 LSAs will get enter into area 0, then exactly. So you do one thing, I mean, because now you are on R1, and even you can see that ASBR is not in our area. See, if this is capital I, it means ASBR is not in our area. I mean, capital I means inter area and small I means intra area. And if it is showing you ABR as I small I, it means this ABR is existing in same area. Have you understood it now? So now the thing is, we have received 60s prefixes. Even you can move on R6 as well. On R6 also you can see show IP route. So all routes are available over here. And if you configure this command show IP OSP border routers, you see 4040 is there as an ASBR, but small I is there because ASBR is also existing in area 2. Have you understood it now completely? So you can also solve this problem with using redistribution, but I'm not going to perform this redistribution anymore. I'm not going to solve this type of problem by using redistribution, right? because if you are performing redistribution and then after you will see that your prefixes will go as external prefixes, and if your prefixes are going as external prefixes in OSPF, then there will be so many changes, right? So how, now if you want to see all those changes, like here you can see that they are going as E1, E2, something. I mean, your external routes can be like E1 routes, your routes can also be E2 routes, right? So we have to discuss the differences in between E1 and E2. I mean, in all these types of routes available, external routes available in OSPF. So I will be discussing all of them, I mean all those differences with you, but for now that's enough, right? So you do one thing more, move on again, R4, say no router OSPF 1, and then say no router OSPF 2 as well, so that it will take neighborship. And now there is no protocol running on this router, right? Do show IP OSPF database, there is nothing in its database table. Once again, say router OSPF 1, router ID is 4.4.4, interface serial 1 by 0, IP OSPF 1, area is what? 1, loopback 1 will also be in area 1. Now interface serial 1 by 1, area will be 2. So once again it will form neighborship, but the thing is, now again prefixes cannot move from one area to another area, because this time again area 2 is not directly connected with backbone area. So it is really mandatory that your regular area must be directly connected with backbone area. But how can we achieve it in this case? By using GRE tunnel. Then after I'll go for virtual link, right? So first of all, I will also solve this problem by using GRE tunnel over here, right? So I'm gonna to perform this GRE tunnel. I know very well that R4's loopback, which is 40.1.1.1, is reachable from R2, is not it? Hello? Yes. Only this area 1 is creating problem. Due to this area 1 only, area 2 is thinking that it is not directly connected with area 0. You understand what I mean to say? But here you know very well that we can configure tunnel interface. I mean, R2 and R4 are reachable to each other, is not it? From R2 you can reach R4, and from R4 you can reach R2 very easily. It means that over area 1, over entire area 1, you can configure a tunnel, is not it? So do one thing, move on R2. As you can see here that it is receiving R4's network here, 40's network. So yeah, it is there, right? So you do one thing, create one tunnel interface, and on tunnel interface, let's say tunnel is 1, IP address I'm gonna to allocate 191.68.1.1 here, and then after I will say tunnel source is what? My loopback 1, and tunnel destination is what? 40.1.1.1. You will see that tunnel interface will come up now automatically, is not it? Now do one thing, move on R4, interface tunnel 1. Hey, you are not required to specify your tunnel mode as GRE over IP, because by default its tunnel mode is what? GRE over IP. So now allocate your IP address as 1.2 here on R4 from the same subnet. Tunnel source is loopback 1, then tunnel destination is what? Now line protocol of this tunnel interface will come up, right? So line protocol of this tunnel interface have came up now. And now you can do one more thing here, because now you have not advertised these tunnel interfaces into any area. Hey, you have not enabled OSPF onto tunnel interfaces yet. As you can see, show IP OSPF interface brief. You see, OSPF is not running on tunnel interfaces yet. On R4 also, OSPF is not running on tunnel interfaces yet. Now you do one thing, from R2 try to communicate with the tunnel IP address on R4. So which was 1.2. So yeah, from here we can easily communicate with 1.2. You understand? And I hope that all of you are remember that how traffic goes through GRE tunnel, is not it? Because I saw we have already gone through it, right? We captured all those packets which were going through the tunnel interface, right? So the entire traffic which was going through your GRE tunnel was having two different IP headers. Do you remember? So in same manner, here traffic is going from R2 to R4, right? Then after configuring these tunnel interfaces, now enable OSPF onto these tunnel interfaces. Say router OSPF 1, not on OSPF 1, go to tunnel interface which was 1 IP OSPF 1 and enable area 0. Enable area 0. So that what will happen, because R2 was already having the complete database of area 0. Try to understand.
Yes.
Area R2 was already having an entire database of area 0, and now I'm gonna to put this tunnel interface in area 0 itself. Then I'll move on R4. I will also put the tunnel interface of R4 inside area 0 itself, so that with using area 0 they will form neighborship now. And because R2 was already having entire database of area 0, so it will give that entire database of area 0 to its OSPF neighbor R4. Hello. And R4 will also advertise its information to R2, and then R2 will further give it to R1. Are you getting my point or not? So right now if you move on R4, because on R4 I have not enabled OSPF on tunnel interface, right? Show IP OSPF protocol, sorry, show IP OSPF, you can run this command. Is it working as an ABR here? Is it working as an ABR? Of course no, it is not working as an ABR. Now you do one thing, move on R2, and I have enabled area 0 here on this tunnel interface at R2. Then let's move on R4 and enable OSPF area 0 on its tunnel interface as well. So go to interface tunnel 1, say IP OSPF 1, area is what? 0. Now you will see that R4 will form neighborship with R2. You see, it has formed a neighborship with R2. So IP OSPF neighbor, let me show you that it is having neighborship with 2222 as well with using tunnel interface, right? So now because now we have put at least one interface in area 0 of R4, that is why it will become now ABR, and also it will be having entire database of area 0 as well. Recursive routing. Oh, yeah, it is happening actually. It will also happen here. The recursive routing is happening here. Because via area 0 it will also advertise its 40s network. So let's do one thing. The loopback of R2, let's advertise it into area 1 itself, so that R4 will start to preferred only intra-area prefix. Hey guys, try to understand. R2 is advertising the loopback of itself in area 0 itself. So do one thing, and now because with using this loopback, they are reachable with each other. They are reachable with each other, and again it is receiving the same prefix on which tunnel is configured via tunnel. So it is performing recursive lookup. That's the problem. That's why tunnel interface is flapping. See, recursive routing. Let me show you here on R2 that on its loopback 1 I'll enable IP OSPF area 1 itself, not area 0. Now there should not be any problem. Is prefix. Yes, it is there as a intra area. Fine. Just wait for a moment. So IP OSPF neighbor. You see, show IP OSPF neighbor. It is having neighborship with it, and then fine. This time it should not have any problem actually. This time it should not have any problem. Previously it was having problem due to recursive routing. Now might be that you people are confused and why it performed recursive routing. See, internal source I was having the loopback of R2 on R2. On R4 also I was having external source as the loopback of R4. The loopback of R4 was advertised into area 1 itself. The loopback of R2 was advertised in area 0 previously. Now, because area 0 and area 1 were, area 1 was directly connected with backbone area, which is area 0. Yeah, that was true. That is why prefixes were going from area 0 to area 1 and area 1 to area 0.
सर अगर हम लोग वेल इंटरफेस उसमें यूज कर लेते हैं उसमें फिर तो ये प्रॉब्लम नहीं आती ना क्योंकि वो हमारा
Exactly. If we would have used on R2 its source address as its serial 1 by 1 IP address, then it could have not occurred. Are you getting my point? My problem, I mean my issue here. See, the problem is, my previously, because the loopback of R2 was advertised into area 0. Now, what happened? Internal source, I took its own IP address, its own loopback interface, right? It was reachable from R4 as a inter area. Try to understand. It was reachable from R4 as a inter area because we advertised the loopback of R2 into area 0. So it was moving on R4 but as a inter area prefix. Inter area prefix. Now, what I did, I configured OSPF neighborship with using tunnel interface, right? So with using area 0. So now R2 transferred its whole database of area 0 to R4 now. Now R4 received the router LSA of R2 via tunnel interface and it received the loopback of R2 as intra area. And you know very well that intra area is always preferred over inter area. So now via tunnel interface itself, it received that route for which was configured as tunnel destination and tunnel source. Are you getting my point?
Yeah.
See, tunnel source and tunnel destination must not be learnt via tunnel. Hello. Tunnel source and tunnel destination must not be learnt via tunnel interface itself. And if those routes are coming through tunnel interface as well, which were configured as tunnel source and tunnel destination, then it will be known as recursive routing. And if recursive routing occurs, it means your tunnel interfaces will be disabled. It means tunnel interfaces will be disabled. Are you okay with this?
Yes.
Fine. Yes.
बट कैनल में जो सोर्स है डिपेंड कर रहा है तो दोनों एक ही एरिया पे होना चाहिए.
It's not mandatory. I just changed the area. It's not that it must be in same area because they were performing recursive lookup. Sorry, not recursive lookup. I said recursive routing. And in tunneling, in GRE tunnel, if recursive routing occurs, then your tunnel will get disabled. Why are you not trying to understand? Okay, you are going to your home, right? And you board train. You are on the train, right? And if train is on you, then what will happen? Why are you not trying to understand this concept? See, tunnel is running. This tunnel interface is running on with using the loopback of R2 and with using the loopback of R4. Now, via tunnel itself, you have learned the loopback of R2. Why are you not trying to understand it? See, you are going in a bus. You are going in a bus, but if bus is on you, so that's called recursive routing actually. This is recursive routing. So you will be disabled, you know. In same manner, tunnel will also get disabled.
But again, it got enabled and never.
Yeah, because if tunnel got disabled, then it will stop to learn.
Okay. Yeah. Sourcing.
Have you understood it or not?
Yes.
So remember that tunnel source and tunnel destination must not be learned through tunnel itself. And if it is coming via tunnel itself, then definitely your tunnel interface will get disabled. Your tunnel will not work. That's why we always say that, okay, like if someone have asked you during interview that due to what reason tunnel interface can go down, so you will simply tell that due to recursive routing.
Even in troubleshooting, they might use this.
They might not. They might. They were having it. Even still they are having this kind of problem in the tissue. I'm talking about lab examination. Fine. So now, because on R4 this problem has been resolved, and now you know why this problem is not occurring. Why is it not occurring now? You know why? Because the loopback of R2 have advertised it into area 1 itself now. Fine. Now area 2 is area 2. I mean, sorry. Now R2 is just exchanging the database of area 0 with R4. Is not it? So still R2 will give its loopback information via tunnel to R4, but via tunnel this time R4 will receive this loopback as inter area, whereas via R3 it is receiving it as intra area. So intra area will always be preferred over inter area. That is why R4 has denied to learn the loopback of R2 via tunnel interface. Try to understand. We put tunnel interface of both routers R2 and R4 into area 0. Now R2 was already having the database of area 0, but this time because the loopback of R2 is not in area 0, however it is in area 0 but in the form of summary LSA, not in the form of router LSA. This time the loopback of R2 is available in the database of area 1 in the form of router LSA. Router LSAs will always be responsible to contain intra-area prefixes, whereas summary LSAs, I mean type 3 LSAs will always be responsible to contain inter-area prefixes, inter-area routes. Fine. So now, because area 2, I mean this R2 has exchanged, this R2 is having neighborship with R4 with using tunnel interface, and in area 0 itself. So what will happen that R2 will exchange the entire database of area 0 with R4. It means that this time R4 is having entire database of area 0. You see, just check it out. How many routers are participating now in area 0? R1, R2 and R4. So that is why here you are having 3 router LSAs in area 0 itself. Then after, you are also having summary LSAs available in area 0. And now because here this time you are having 2 ABRs, R2 and that is why summary LSAs have been generated by R2 as well as R4. And you see, now it is also handling data of area 1 as well as of area 2. So how many routers were there in area 2? 3, 4, 5 and 6. But here you can see that summary LSAs have been generated by R4 only, because for area 2 here we are having only one ABR, which is R4. So you can do one thing, you can move on R6, and on R6 also you can run this command to IP OSP border router now. So you can see 444 is working as an ABR. And there is no problem now. So IP route, you can see that all routes are available over there as inter area. So from here you can ping with 10.1.1.1, which is available on R1. Have you understood it now? Fine. Any problem? Good. So this is that how can we solve this problem by using GRE tunnel. Now let's do one more thing. Let's move again back on R4 and say no router OSPF 1. On R2 also say no interface tunnel 1. I removed it now. And then let's move back again on R4. Say router OSPF 1. Router ID is what? 4.4.4. Interface serial 1 by 0. IP OSPF 1. Area is going to be 1. Interface loopback 1 will also be in area 1. And interface serial 1 by 1. Area will be 2. Show IP OSPF interface brief. Fine. And once again you will see that there will not be any route available on R5 and R6. Show IP OSPF board or router. Let me show you. Nothing. Show IP route. Nothing. Only intra area. Show IP OSPF database. Nothing. Nothing. Gone. This time we are going to use here virtual link. I'll solve this problem by configuring virtual link. Fine. Let's move on R3. Check database table of R3. It is handling or it is having database of area 1 only. Check it out. Is not it? It is having database of area 1. This R3. Then move on R4. R4 is also having the database of area 1 and area 2 only. Check it out. It is having database of area 1 and database of area 2. Is there any summary LSA for area 2? Why? Because it does not have any ABR for area 2. So if you do not have any ABR for any specific area, then you will never find summary LSAs in that area. So this time there is no ABR for area 2. That is why there is no summary LSA available for area 2. And that is why you cannot find any summary LSA in the database table of area 2. Any problem? Fine. Then after it, because this on this R4 you can also see it is not having any data, database of area 0 at all, right? It does not have any information of area 0. Now let's do one thing. See, let's move on R2 now. Are you getting my point or not? And let me capture this link. I've captured this link. See, I'll configure virtual link on R2 only. When we configure virtual link, what is the command? Area 1 virtual link with whom? The router ID. And this time you do not have that router ID available in your routing table. Do you have? Because I have not configured these router IDs on any interface here. But still you will say that area 1 virtual link with whom? How will it be possible to send hello packets to a router ID? However, this router ID is not available inside its routing table. So how? See what will happen. Let me tell you. Once you will configure this command, area 1 virtual link with 44444. After configuring this command, this router will regenerate its own router LSA. That I am the endpoint of virtual link. I am the endpoint of virtual.
Okay, so that's the end of today's video. So I hope you learned something new today. We'll be coming with few more videos of OSPF, guys. See you later. Thank you.